Okay, so our intersection is 0.178 and 1. For region S, the sine graph is on top, the bottom is the 4 to the negative x. And then for region R, 4 to negative x is on top, and the bottom is the 1 plus 4 sine, 1 4 plus sine pi x. Careful though, for the bottom function for area R has multiple terms, so we definitely need a set of parentheses to distribute that negative through. Or if you're having y1 and y2 hold your two functions, then you can just subtract it without using parentheses. But just if you're writing those terms out, you want to use parentheses. Okay, so part C and D deals with volume. I just want to walk around to see, are we getting it? Does it make sense? Anytime you see rotation, it's either disk or washer method. And then if it's cross section, figure out what direction they're describing to build the base, and then build the area, and then put integral around it. Okay. All right, let's just see where we are. Okay, for part C, we should definitely be thinking about washer method. I mean, there's no flat surfaces anywhere on the shader regional except at x equals 0. But there's obviously a gap. We have to draw two radius. Make sure that when you draw your radius, that both your radius involves the dotted line. And once you have your radius built, then look at where the ends of your radius are touching. And those are what you want to involve to subtract to build your big R and little r. You've already gathered all the bounds from part A, so you just pull those values that you need. And this is where, having your y1 and y2 hold your two radius, I find that really beneficial. There's less parentheses you have to worry about. So, but it's not wrong. If you want to put everything on just into the same line, you can. You just have to, just be careful with your parentheses as you build out your formula. Okay, try part D. Okay, for part D, it says the enclosed region is a base of a solid. The cross section parallel to the y-axis. So think about that, parallel to the y-axis. Y-axis is this way. Parallel means we're going to stay vertical. Isosceles right triangle with leg on the base. So there's a formula for that. And then, but we first build our base first, which is simply just top minus bottom. And then isosceles right triangle with leg on base is 1/2 base squared. So once you have your base expression, then move up to the area representation. And then once you have the area representation, then it gets a lot easier. Then you're just putting an integral around that area expression and including the bounds from left to right. It'll be the same as part C. I'm sorry, same as part B. So we're doing a little that little sliver on the left side there. All right, any questions? Page 3. Page 4. Okay, given the region below, we have natural log of 4 minus x. That's the curve. It's that downward curve. The line x equals -1 and the x-axis. I just want to point out that sometimes the x or y-axis sometimes act as just reference points. They may not act as boundaries. So in this case, the y-axis is not a boundary because the boundary is the -1, the x-axis, and the downward curve. So I see some students they treat every axis as the boundary, and that throws things off because then they start building radius that's not. So just know that in this case, the y-axis is just background representation. It's not really a boundary here. So, but go ahead and shade in your graph so you know the boundaries that you're considering. Okay, we're going to rotate around the line x equals -1. Anytime you see the word rotation, revolving, axis of revolution, you know it's got to be either disk or washer method. Okay, so try that. See if you can draw your axis. Decide, is it washer? Is it disk method? How's my radius going to look? this entire, it's the y-axis. So the shaded region is going to extend all the way over. So good. So most of you guys are setting it up as this method and horizontal radius, which also means we have to rewrite our equation. Okay, no gap. All we need is one radius. But you see a horizontal radius, so you know these equations are not going to be in a good fit, not really suitable for our top, for anything that right minus left. It's good for top minus bottom, but not for right minus left. So we're going to solve for x. To solve for x, we have to do some algebraic steps here. I want to solve for x. I have to get rid of that natural log, so I'll raise both sides with e as the base. E and natural log cancels out. Now I'm just going to move x around so I can get that positive x. So I'm going to subtract the e to the y, and I'm going to move that x to the right. And now this is the equation I want to use to represent that curve. So for this method, all we need are two boundaries here. We have 4 minus e to the y and x equals -1. So that will help us get to our big radius. Right minus left, right endpoint is sitting on the 4 minus e to the y. Left endpoint is sitting on the -1. Careful though that we got to keep track of two negatives there. Two negatives makes positive. Now we have to think about bounds. Bounds, if our expression is in terms of y, our bounds are also in terms of y. So lowest y value is 0. That's easy to spot. The highest y value is going to be wherever this is the y-intercept, not y-intercept, but this is, we know that this is the natural log of 4 minus x. And if I plug -1 in for natural log 4 minus x, it will give me the y value. So there's no need to use these adjusted equation. We just use the original equation and plug -1 in and get the y value off of the graph here. So natural log of 4 minus -1, which is just natural log of 5. .609 is what I got there. So we're going to go as far down as 0 and as far up as 1.609. And then big radius squared. Because we're doing volume. Okay, enter in your calculator. Okay, try part B. Okay, so hopefully we can see that this is just going to end up being washer method because our dotted line is going to be clearly not up against the flat surface. We need to draw two radius. But the good thing is that we already have everything built from part A. Our equations has been rewritten. Our bounds has been found, so we can just carry a lot of information over from part A, since we already have our equation in place. Okay, part C, parallel to the x-axis. And it's a rectangle, so remember with rectangles, it's base times height. You can build the base, but the height is always provided for you. They always describe to you what to do to fill in that height. Either they connect it with something in relation to the base, or they'll tell you the height is this number. Okay, parallel to the x-axis, which direction is that? Horizontal, yeah. X-axis is this way, parallel, we're still. Notice that we're not going to be squaring here because we already have our base and height, and it looks like the height is just a number, so it's just 4 times 5 minus e to the y. We don't square this. We already have our 2 dimensions here. Height is just 4. Okay, our last problem here, page 5. We already saw something like this before, but let's just practice it now with volume involved as well. So we'll finish off with page 5, A, B, and C. Okay, you may need your calculator to find those bounds that you need for area. Any questions? Page 4. Top minus bottom for part A. For part B, find the area of S. We can kind of brute force it and think of S as 3 separate regions. But the more elegant way to work through S is find the area of R plus S. Treat this like one region. Find the area of that, and then simply subtract R. And once you do that, then you're left with region S. So find this region first. So yeah, so ignore that y equals 2. do top minus bottom for that shaded region, and then you get subtract out per day. Okay, part C, decide. It says write but do not evaluate, so you can just set up the formula. Decide whether it's disk or washer method. Right, it ends up being washer method because there's a gap between our shader region and our dotted line. So from the dotted line, you're going to draw two radius, one that extends all the way to the top of the curve, and the other one just extends to the y equals 2 line. Okay, any questions? Okay, so no homework except Monday I'll check pages 3 through 5, beginning of class. I'm going to adjust the schedule a little bit for next week. So what I want to do is I want to start AP review. There's one very particular type of free response question that I want us to do, or a type involving antiderivatives. So I'll let do that Monday and Tuesday. But I will still want to have another review day for our quiz. So I'm pushing the quiz to next Thursday. So Monday and Tuesday, we'll do antiderivative FRQs. We can still do some review. And then Wednesday, we'll do another day of class review. And then I'll have help sessions Wednesday morning and Thursday morning, definitely Thursday morning. And then your quiz will be Thursday, okay, with calculator. Okay. All right, go get your phones.